in exercise 1.4. So before moving to the exercise, let us learn the representation of functions to make you understand more about true sums. Okay. So here representation of function is represented in four ways. Representation of functions. So the first one is a set of ordered pair. A set of ordered pair. Already we have learned what is ordered pair. Okay, set of ordered pair. And second one is a table form. A table form. Okay. And the third one is an arrow diagram. Okay. And the fourth one is a graphical form. Okay, so representation of functions are made through all these four: a set of ordered pair, a table form, an arrow diagram, and a graphical form. Okay, now let us learn each and everything. What is ordered pair? Make a note of it. Ordered pair is set of ordered pair. Set of ordered pair is f is equal to x comma y, such that y is equal to f of x belongs to a. Okay. Of all ordered pair represent all ordered pair represents a function. Okay, and second one is a table form. Make a note of this, a table form. A table form is nothing but the value of x. The value of x and the value of the representative. Respective images under f. Okay. And the third one is an arrow diagram. An arrow diagram indicates elements of domain. So it indicates elements of domain of f and the respective images and their respective images by means of arrows. Okay, and the third one is graph, and the fourth one is graphical form. It's nothing but it is drawn under xy plane. It's a graphical form. Okay, the same thing. F is equal to x comma y, such that y is equal to f of x. X belongs to a. Okay, or plotted as a point. Points on xy plane. Okay, now here set of ordered pair is nothing but f is equal to x comma y, such that y is equal to f of x and x belongs to a. So all the elements this belongs to x belongs to a. All ordered pair represents a function. All ordered pair represents a function within bracket as we have learned already. So within bracket x comma y. So if it is 3 comma 4, 5 comma 3. So these are the examples. All ordered pair represents a function. A table form, the value of x and the value of the respective images under f. Value of x and the value of the respective images. So let us consider that as x and f of x. It's in the form of table. Okay, the same elements, that is the value of x and f of x is like this. It goes on. This is in the form of table form. An arrow diagram. Arrow diagram indicates the elements of domain of f. Domain of f and the respective images by means of arrows. Arrow diagram we know very well. So arrow diagram, the elements of x. If we are considering as A and B. Okay. So if we take the elements of same thing, for example, this also right. Okay. So if we take f of x is equal to 3, 5 and 6 and 4, 3 and 8, it is represented through arrow diagram. Okay. So it indicates the elements of domain of f and the respective images by means of arrows. And the fourth one is a graphical form. A graphical form, already you know very well, it is drawn under xy plane. Xy plane is nothing but like this. So if you take x dash and y dash, y, okay, y dash. Okay, now, so f is equal to x comma y such that y is equal to f of x belongs to a. Same, just you have to plot the points x and x dash, y and y dash, xy plane axis. Okay, it's very simple. It comes under 5 marks for your examination. Let us know. And one more point in the graph is every function can be represented. Every function can be represented by a curve in a graph. Every function can be represented by a curve in a graph. Okay. And one more thing is a vertical line test. What is meant by vertical line test? Take down, pause the video and take down. Okay. What is meant by vertical line test? Vertical line test is a very simple form. Just you have to draw another vertical line and check out whether it intersects at one point. What you have to check out? You have to check out whether it intersects at one point. If it is more than one point, it is not a function. If it intersects at one point, it is a function. Okay, now let us see with the example. Next one is vertical line test. Vertical line test. Okay, if every vertical line intersects at a curve, so every vertical intersects the curve, in at most one point. So you have to keep in mind that it must intersect at one point. One point, it is a function. If it is more than one point, it is not a function. Let us have an example. Okay. So all the examples from your textbook only. So that it will be very helpful for you to go through, isn't it? That's why I am taking that. So x dash, y dash, x and y. Okay. If a graph is given like this is a graph. So it is given with a curve. You have to test whether it is a function or not. For testing, you draw another vertical line. So here I am drawing a vertical line. Now you can see the curve intersect at one point and the second point. It intersects at 2 points, isn't it? So if it intersected 2 points, you can write that it intersects at 2 points. 2 points, and therefore it is not a function. Okay, that's all. If suppose if we have some other curve like this, okay. Okay, now here this is the question. If I draw a vertical line, here you can see it meets at 3 points, more than 1 point. If it intersects at 3 points, again it is not a function. Okay. Now let us have one more example. Okay. Now this is the question. If I draw a vertical line over this, it intersects at 1 point. You can see it intersected 1 point, therefore it is a function. It intersects at 1 point, it is a function. It is a function. Okay, so it is very easy vertical line test. Okay. Now the next one is we are going to see about types of function. Different types of function. So there are different types of function. Let us know how to identify the type of function. Make a note. Okay. Types of functions. If everyone, so first one is 1 to 1. First one is 1 to 1, and second one is many to 1. Many to 1, and the third one is on to, and the fourth one is into. Okay, there are 4 different functions. One is 1 to 1, another is many to 1, and the third one is on to, and the fourth one is into. Okay, now let us see the how to identify the type. 1 to 1. If it is 1 to 1 function, 1 to 1 function, let us have an example here. If the calls and the friends, we'll take one example, call 1, call 2 and call 3, and friends, friend A, friend B, C, D and H. Okay, friend calls from, usually if you call to your friend, if you give a call to your friend, one call at a time, if I am giving to one call at a time, C to 1, okay, and if I have A to 2 and 3 to D, we can give to anyone, no problem. If the call is given one call at a time, to a friend, okay, that is called as 1 to 1 function. It has another name as injection. You can call has another name as injection. Here you can see one call is made at a time to your friend. So A is calling one call at a time, and D is calling one call at a time. One call is made to your friend at a time is called as 1 to 1 function. And the second one is many to 1. Many to 1. Make a note. Many to 1 function is if you have a person, number of persons and things. Okay. We can see there are 3 fields in data complex. So nowadays we have in a data complex first floor, second floor and third floor. In one complex itself there we have they will be releasing three flames, isn't it? In floor 1, floor 2 and floor 3. Or else we can take this as flame 1, flame 2 and flame 3. We have to select a particular flame what we are going to watch, isn't it? In one complex itself they will be giving tickets for three flames. Okay, so person 1, person 2, person 3, person 4, person 5, person 6 and person 7. So if considering the relation arranged to buy a ticket, because then one person may choose to watch the same film. So if suppose if person 1 is wishing to watch film 2, okay, and person 2 is wishing to watch film 2, and person 3 is wishing to watch film 1, and person 4 is wishing to watch film 3, and person 5 is wishing to watch film 1. Likewise, person 6 wish to watch film 3. Person 7 also wishes to watch film 3. Okay. Can you able to understand? If one film is wished to, one film is, the number of person is wishing to watch film 1 is P3 and P5. So you can see more than one is willing to watch film 1. Here also film 3 more than one person, that is 3 persons are wishing to watch the particular film. So if it happens like that, it comes under many to one function. Many to one function. Many to one function. Many persons willing to watch one particular film. Okay. Now, in other words, we can take this as f such that a to b is a function many to one if it is not 1 to 1. And you have a clue. If it is not 1 to 1, if it is not 1 to 1, if it is not 1 to 1, it is many to 1. It is clear, no? If it is not 1 to 1, one call may to a friend and one call to another friend. One call to, this is 1 to 1. One image, okay, 1 to 1. But here the condition differs. So here we have more than one person is willing to watch a particular one film. So it is very clear that if it is not 1 to, it is many to 1. If it is not 1 to 1, it is many to 1. Okay. And the next one is on to function. On to function. What is on to function? On to function is the calls and the persons. Calls and persons. Okay. So call 1, call 2, call 3, call 4 and call 5. Person 1, person 2 and person 3. So now if I take with this example, call 1 and call 3. Call 1 and call 3 has been done for person 2. Okay. And call 4 and call 5 to the person 3. Okay. So here we can see 3 persons are in contact. 3 persons are in contact. Okay, 3 persons. If every person in contact receives a call, if every person in contact receives a call, then the function is on to function. Okay, if every person is in contact receives a call, every person must receive a call, then the function is called as on to function. Here it is given that its another name is also called as subjection. It has another name, it is called subjection. Subjection. Okay, so for one to one it is called as injection, and on to function it is called as subjection. And one more thing we have is bijection. What is meant by bijection? Okay, if f such that a to b is both one to one and on to. So you can make a note that if it is both one to one and on to, it is called as bijection. Okay. So when we are asked to check out with bijection, we have to check out whether the function is on to as well as one to one. If the condition applies for both one to one and on to, it is a bijection. Okay. And the next one is into function. What is it? This into function. What is into function? Into function. If a customer and a product, let us have an example as customer and products. Okay, so customer 1, customer 2, customer 3. Let us have with our day-to-day things as television. Okay, television, washing machine. Television, washing machine. Okay, air conditioner. You can refer your textbook. That's why I'm taking all the examples from your book only. So what I read. Okay, so if customer 1 chooses both television and washing machine. Okay, customer 1 chooses both television as well as washing machine, and customer 2 selects washing machine, and customer 3 selects water heater. Okay, now you can see that here the leftover thing is air conditioner. So no one choose air conditioner. If this represents this represents as into function. Okay, and if there exists only, you have a clue. If there exists only one element, if there exists at least one element, you can take a word as at least one. If at least one is left over, one element in B, that is product B. So here we will take customer as A. Okay, product B which is not the image of any element A. Okay, so therefore F such that A to B is into. Okay, if it is not onto. Okay, now here It is given that if it is into function, if customer C1, C2 and C3 and the products as B, the products are television, washing machine, air conditioner, water heater. If no one is selecting air conditioner, so you have to check up with B whether at least one element exists. One element exists in B which is not the image of, which does not have the image of A, which does not have the image of A, it is called as into function. And one more thing, there is a clue that f such that A to B is into. If it is into, if it is not onto, it is into. If it is not onto, if it is not onto, what is the condition for onto? If every person in contact receives a call, then the function is onto. If it is not onto, it is into. Okay, you have a clue that if it is not onto, we can consider that as into. Okay, because here every element, every person receives a call, isn't it? If it is not onto, it is into. Okay, and now let us see some special cases of function. Special cases of function. What are the special cases of function? One is constant. Okay, let us see with the figure. Ask the video and take note. Everything will be there in the video itself. If you find any blur in your video, what you have to do is you have to go to the right corner of your mobile. At the right corner of your mobile, you can find three dots. In that, you select quality. In that, go with advanced. Then select 480 pixel or 720 pixel. Okay. Now, special cases of function. What are the special cases of function? Okay. So first one is constant function. Constant function. Second is identity function. Okay. And the third one is real valued function. Real valued function. Okay. So the first one is constant function. Constant function is nothing but every element of A. So let us have A, B, C, D, and here let us have 1, 2, 3. Okay, every element of A has a constant image over B. No change. Okay, every element of A has a image over B. Here, 3 has image over A, B, C, and D. Okay, so range, we can take this as range of F. Range of F is equal to only 3. F is a constant. F is constant. No change. F is constant. Okay. And the second one is identity function. What is meant by identity function? Identity function is nothing but each and every element of A as XYZ, and here also XYZ. No change. So X has, okay, this type of arrow diagram represents a identity function. Here you can see X as image over X and Y as image over Y and Z as image over Y. Okay, each element has a image and it is denoted by identity function I small base we take as capital A. Okay, and what about third one? Third one is real value function. Real value function. Okay, what is real value function? If the range of F if the range of F is a subset of the set of all real number R. Okay, so f of A is a subset of real number for all. Okay, so A belongs to capital A. Okay, real valued function is if the range of F is a subset of the set. If it is a subset of set of all real numbers, F of A. So taking that as subset of real number, this is called as for all. You can read it as for all. So A belongs to A small a belongs to capital A. Okay. Now let us go with exercise 1.4. Okay, take down. Pause the video and take down now. Very easy exercise 1.4. You will be getting 5 marks in this. So exercise 1.4. Question number 1. Determine whether the graph of the given below represents a function. So you have to check whether, I'll write the question in short form, determine whether it is a function. Whether it is a function. Whether it represents a function. Okay? And give reason. You have to give a reason whether it is a function or not a function. Okay? So question number 1. A graph is given. Okay? So y x dash, y dash, x. And question number 2. Question number 3. X dash, y dash. Okay. And question number 4. Okay. Now you have to give a reason. If it is a function or not a function, you have to give reason. Okay. This very simple thing. If it intersects at more than one point, it is not a function. If it intersects at one point, it is a function. That is enough. Okay. Now you can find these are the questions. Okay. Now I am going to draw a vertical line over this given curve. So if I draw a line over this, here it intersects at 2 points. You can find it intersects at 2 points. Now what is the reason? It intersects at 2 points or more than 1 point. It intersects at 2 points. Okay, therefore it is not a function. That's all. Okay, and question number 2. Here you can find, if I draw a line over here, it intersects at one point. Even you can draw this side. Okay, it is not the condition, you have to go with the positive side. Either any one of the side you can draw a line. Okay, if I draw here also, it intersects at only one point. No problem. Either you are drawing this side or that side. That is not the problem. Here it intersects. Therefore, it intersects. The graph intersects, or otherwise you can write as the graph meets the vertical line and the graph meets the graph meets the vertical line at one point. Otherwise, it intersects at one point. One point. Therefore, it is a function. It is a function. One point means it is a function. And here, if we draw a vertical line over here, 1, 2, and 3, more than one point, isn't it? It intersects at more than one point. Therefore, it is not a function. Okay, it is not a function. And the fourth one is, if I draw a line here, it intersects at one point. So therefore, what is the reason we can give? It intersects at one point. One point, therefore, it is a function. Okay, very simple, isn't it? Okay, take down. Now let us go ahead. Go to question number 2. You can pause the video. Pause the video and take down now. Question number 2. Let f such that a to b be a function defined by f of x is equal to x by 2 minus 1. Okay, where a is equal to 2, 4, 6, 10, 12, and b is equal to 0, 1, 2, 4, 5, 9. Represented f by, you have to find a set of ordered pair. Set of ordered pair and the fourth one is a graph. Okay. Now, so if such that a to b be a function defined by f of x is equal to x by 2 minus 1. So taking this, and here is the condition that a and b, the elements of a and b are given. You have to go with a set of ordered pair, a table, an arrow diagram, and a graph. Okay. So and hence it is given that function f is a to b. So taking the elements of a, you have to find the set of ordered pairs. Okay. So first I am going with f of x is equal to x by 2 minus 1. And taking f of x, so f such that a to b. So take the elements of a. You have to consider the elements of a. So first I am taking f of 2. Okay, like this. Then the next one is f of 4. Okay, then f of 6. Likewise, you have to find f of 10. Then f of 12. Okay, you have to solve using this x by 2 minus 1. So here, in the place of x, if it is f of x, it is x. If it is 2, in the place of x, you have to write 2. 2 by 2 minus 1. So 2 divided by 2. 2 divided by 2 is 2 ones are 2. So therefore, 1 minus 1 is equal to 0. Very clear? And then, okay, then f of 2. What is f of 2? Same condition. 4 divided 4 by 2 minus 1. So 2 ones are 2 twos are. So 2 minus 1. 2 minus 1 is equal to 1. Okay? And then f of 6. What is f of 6? F of 6. Same. Here 6 divided by 2 minus 1. 2 ones are 2 threes are. 3 minus 1 is equal to 2. Okay, so f of 6 is equal to 2. And here f of 10. So 10 divided by 2 minus 1. 2 ones are 2, 5s are. 5 minus 1 is equal to 4. Okay, likewise if we go over there, 12, f of 12. So 12 divided by 2 minus 1 is equal to 2 ones are 2, 6 are. 6 minus 1 is equal to 5. Okay, now let us go and find the set of ordered pair. Set of ordered pair, then table, arrow diagram, and graph. Okay. Okay, first one is set of ordered pair. So if you find set of ordered pair, through that you can find all the three. Very simple it is. So here, while writing set of ordered pair, write as f. F is equal to within set bracket, open bracket here, 2 comma. Now I tell you, f of x is 2 and the value is 0. So 2 comma 0, 4 comma 1, 6 comma 2. Likewise you have to write. So here it is 2 comma 0 and 4 comma 1, 6 comma 2, 10 comma 4 and 12 comma 5. Okay, that's all. Set of ordered pair is very simple. Okay, and question number 2. So here our table. What you have to do for a table? So take as x and f of x as 2. This is our table. Okay, with using the ordered pair, you comma 4 and 12 comma 5. 12 comma 5. And here you can find 9 is left over. That's what I told you. You should not take and write directly. If you have taken directly, everything will go with an image and 9 will not be seen and your sum will go wrong. After seeing this only, you will get whether arrow diagram is correct or wrong. Marks will be given. Okay. So you have to take the elements from elements of A and B from question. And then fourth one is a graph. What about graph? Normal sheet. Draw a line like this using scale. Take 1 centimeter, 1 unit, and check up whether the x-axis is greater. X-axis is the highest value. X is the x highest value is 12. So you have to plot here as 2 points. Okay, 2, 4, 6, 8, 10, 12, 14. Okay, and for y here 0, 1, 2, 4 and 5. 5 is greater. So you can go with 1 unit. One, two, three, 4, 5 and 6. So this is x dash, y dash. Okay, 2 comma 0. So plot here as 2 comma 0. So 2 and 0 is here. So 2 comma 0 and write as 2 comma 0. Okay, then 4 comma 1. 4 in 4 it is 4 comma 1. Write as 4 comma 1. Okay, and then 6 comma 2. 6 comma 2. Okay, and 10 to 4. 10 comma 4. 10 comma 4. And then it is 12 comma 5. 12 comma 12 comma 5. This is enough. You need not plot any points. You need not join any points. Okay. Okay, all these are very simple, isn't it? So for solving this, you will be getting 1 mark and 1, 2, 3 and 4. 4 marks plus 1, this is 5 marks. Okay, very simple. Take down, pass the video and take down and move on to question number 3. Question number 3. Represent the function f is equal to 1 comma 2, 2 comma 2, 3 comma 2, 4 comma 3 and 5 comma 4. So you have to represent it through an arrow diagram, a table form and a graph. So first one is an arrow diagram. And second, you have to find a table form. And the third one is a graph. Okay, here it is given us directly. So f is equal to 1 comma 2. So it is given directly, very simple. You have to just show with the arrow diagram, table form and a graph. Okay. So for arrow diagram, it is not given either it is a or b, x or y. So we can 2. 1 to 2. Mark here, write as 1 comma 2. And then 2 comma 2. 2 comma 2. And 3 comma 2. 3 comma 2. And 4 comma 3. 4 comma 3. And then 5 comma 4. Okay, that's all right. Take down. Pause the video and take down one. It will be there in the video. Question number 4. Show that the function f to f such that you have to show that function n to n is nothing but natural number to natural number defined by f of x is equal to 2x minus 1 is 1 to 1 but not on 2. 1 to 1 but not on 2. So you have to show that it is 1 to 1. You have to show it is 1 to 1. Okay? Now, hence it is given as n to n function and the f of x is given. So what is the n? N is equal to natural number. So it starts from 1, right? Only 1 to 5 and remaining as ellipses. So n is n to n. Accordingly, I have to take f of x is equal to 2x minus 1. Okay? So in the place of x, you have to apply the value of n. So 1 is equal to 2 within bracket. In the place of x, here 2 into x. So 2 into x is 1 minus 1. So 2 ones are 2. 2 minus 1 is equal to 1. Okay, then go with 2. F of 2 is equal to 2 within bracket 2 minus 1. 2 2s are 4. 4 minus 1 is equal to 3. And f of 3 is equal to 2 within bracket 3 minus 1. 3 2s are 6 minus 1 is equal to 5. And f of 4, 2 within bracket 4. 4 2s are 8. 8 minus 1 is equal to 7. Okay, so with that we have to draw a arrow diagram so that we can check up whether it comes, whether it is 1 to 1 but not on 2. Enough for finding 5. It goes on, isn't it? So 5 is enough. So using arrow diagram, let us check out the function. Arrow diagram, and here it is given as n to n. So write as n and the n. So better go with natural numbers. So 1, 2, 3, 4, 5, 6, 7 as it goes on. Okay. Need not write all the numbers. Here also 1, 2, 3, 4, 5, 6, 7 goes on. Okay. Now let us draw an arrow diagram. For f of 1 it is 1. F of 1. So f of 1 is 1. Right? And f of 2. F of 2 it is 3. F of 2 it is 3. And f of 3 it is 5. F of 3 it is 5. And for f of 4 it is 7. And for 5 is a one-to-one function said to be ortho function if the range and domain are equal, isn't it? So what about the range? Range is equal to what are the range? Range is equal to 1, 3, 5, 7 and 9. What are the elements which has image? 1, 3, 5, 7 and then 9. So 1, 3, 5, 7, 9 and it moves on. Okay. And what about the codomain? Codomain is all the elements. Codomain is all the elements which is present here. All the elements. What are all the elements? So we can take that as 1, 2, 3, 4, 5. Okay. You have to be very careful with codomain. Codomain is the element which is present in X in Y. Okay. That is here we are taking this as N. All the elements which is present in Y. Okay, codomain. And what is range? Range is nothing but which has a pre-image over N. So 1, 3, 5, 7 and 9. Always you can keep that in mind. The values which we have find for finding f of x using f of x. Okay. And here therefore range is not equal to codomain. Therefore range differs. Range is not equal to codomain. Range is not equal to codomain. Therefore this condition applies. What is the condition? Therefore it is 1 to 1 but not 1 to 2. It is 1 to 1 but not 1 to 2. Okay, very simple. Take your. Let us go with question number 5. Make a note of this. Pause the video and take down. Okay. Okay, question number 5. Show that the function f such that n to n. Again it is a natural number to natural number defined by f of m. And the equation is given as m square plus m plus 3. Okay, using this you have to solve and find whether it is one-to-one function. Okay, now hence it is given as n to n natural numbers. What is n? N is equal to 1, 2, 3. As in earlier sum we have learned. So go with 1 to 5. Remaining things need not write. N to n. So f of m is given. F of m is equal to m square plus m plus 3. Okay. Using the elements which is present in n. Now let us go with f of 1. So in the place of m, apply the value of f of m. So 1 square plus 1 plus 3. So 1 into 1. 1 into 1 is 1 plus 1 plus 3. So 3 plus 1, 4. 4 plus 1, 5. Okay. Then go with f of 2 is equal to 2 square plus 1 plus 3. 2 into 2 is 4 plus 1 plus 3. That is 4 plus 1, 5. 5 plus 3 is equal to 8. Okay. Then go with f of 3. So here in the place of m, write 3 square plus m. M is 3. Okay. Here I have written 1, isn't it? Here it is 2. So 2 plus 3 Now plus 3. So 3 into 3 is equal to 9 plus 3 plus 3. 9 plus 3, 12. 12 plus 3 is equal to 15. So then you can keep finger and write. Okay, m square. So 4 square plus m is 4 plus 3. So that we won't do mistake. 4 into 4 it is 16 plus 4 plus 3. Okay, 20. 20 plus 3, 23. Then f of 5 is equal to 5 square plus 5 plus 3. So 5 into 5 is equal to 25 plus 5 plus 3. 30. 30 plus 3, 33. Okay, this is enough. And you have to find whether it is one-to-one function. Okay, so to find whether it is a one-to-one function, we can use arrow diagram. So it is given as n to n. What is n? Write all the natural numbers, write ellipses. Okay, so as it goes on. So here you can 5, isn't it? 5, 9, 15, 23. Even you can write that directly also. Writing ellipses. See how I am writing. In between you can leave values. Write 5, then two values 9, then 15, like that. 23, and it goes on. 23, 33. Okay. Okay, 1, 2, 5, then give us dot 9, dot 15, 23, dot 33, like this. Okay, now let us draw an arrow diagram. So for 1 it is 5, for 2 it is 9, and for 3 it is 15, and for 4 it is 23, and 5 it is 33. So for 1 it is 5. Okay, for 2 it is 9, and for 3 it is 15, and 4, 20, 5, 33. Okay, now what we are asked is, we are asked to find whether it is one-to-one. How to prove that it is one-to-one function? One-to-one. Here domain, codomain is also a natural number, isn't it? Codomain is also a natural number. What will be the range? Range is equal to, what is range? Already we have discussed, isn't it? So 5, 9, 15, 23 and 33. 5, 9, 15, 23 and 33. Okay, and also it is not as end, no? We are finding only for 5 elements. Okay. Then, hence it is from 1 to 1. F such that n to n is given as n to n, therefore it is 1 to 1 function. 1 to 1 function. 1 to 1 function. Why? Because one element of n has a pre-image over domain, isn't it? So it is 1 to 1 function. Take down and go with the next question. Here we can have that the domain and both are not equal also. Last system we have written this thing, you can do the same condition also. Okay. Now question number 6. Let A is equal to 1, 2, 3, 4. Okay, and B is equal to n. B is equal to n, and F such that A to B. be defined as b as f of x is equal to x cube. X cube, then you have to find the range of f. Find the range of f. Okay. And question number 2 is identify the type of function. Identify type of function. Here it is given as a is equal to 1, 2, 3 and 4 and b is equal to n. What is n? N is a natural number, isn't it? Okay. Find the range of f. So and here it is given as f of x. F of x is equal to x cube. F of x is equal to x cube. And here f such that a to b. What is a to b? So go with the element of a. So 1, 2, 3 and 4. So f of 1 and then f of 2, f of 3 and f of 4. Okay. So it is x cube. 1 cube, 2 cube, 3 cube and 4 cube. 1 into 1 into 1. If you want, you can write is equal to 1. 2 cube, 2 into 2 into 2. That is 2 2s are 4, 4 2s are 8. 3 into 3 into 3. 3 3s are 9, 9 3s are 27. 4 into 4 into 4. 4 4s are 16, 16 into 4, 64. Okay. Now, you have to find the range. So, you have to find the range. Just you have to take down and write whether f is equal to. So 1 it is f is equal to the range f is equal to 1, 8, 20, 27 and 64. 1, 8, 27 and 64. Okay, question number 2. Identify the type of function. So you have to identify the type of function. To identify the type of function, go with arrow diagram. Okay. So here it is given as a and b. A is 1, 2, 3 and 4. What is b? B is a natural number. B is a natural number, starts with 1, 2, 3, 4, 5 as it goes on. Okay, now just for 1 it is 1, 2 it is 8, 1 it is 1, okay, 2 it is 8, here we have 8 and 3 it is 27, or else write directly as we have written earlier now. So write as 3, 4. Write directly the values. So 27, 64, so that it won't confuse you. Okay, for 2 it is 8 and 3 it is 27 and 4 it is 64. And here we are asked us to find the type of function, isn't it? Let us find the type. So codomain. What is codomain? Codomain is equal to 1, 2, 3. So all the elements which is present in B is codomain. Okay, what about range? range f is equal to, range f is 27, 64, goes on. Different elements have different images. Different elements have different images over domain and codomain. Codomain and range. So codomain is not equal to range. Codomain is not equal to range. So both are not equal. So therefore it is one-to-one function. It is one-to-one. So therefore it is one-to-one. Okay? Codomain and range are not equal. Okay then. Let us go with question number 7. So here in question number 7, in each of the following cases state whether the function is bijective or not. You have to check up whether it is a bijective or not. Okay? Okay, otherwise you try 7th question. I'll just explain you in the next video. We will go with question number 7 and follow the remaining sums. In each of the following cases, state whether the function is bijective or not. Justify your answer. So you have two sub questions. F such that R to R defined by f of x is equal to 2x plus 1. And then F in the second question, R to R is defined by f of x 3 minus 4x square. So just try this sum. We'll do this sum in the next session. Okay. Thank you, students.